Welcome to Coach Eichner's Math. Today we're going to talk some more triangle congruence. We've already discussed side-side-side congruence and side-angle-side congruence. So we're going to go and add to those and talk about angle-side-angle congruence. Okay? If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles must be congruent. So just like we talked about with side, angle, side, my angle was included. Now I'm talking about included being my side. So my included piece would be the side, AB or DE. My angle would be angle A and angle D, and angle B and angle E. Notice how these pieces are all touching each other. They're all adjacent pieces of my puzzle as I'm looking at this. So we're going to go ahead and start and say angle B is congruent to angle E. We're going to say segment AB is congruent to segment DE. And then we're going to say that angle A is congruent to angle D. Now, because we know that those three pieces work, angle, side, angle is a postulate that proves congruence of a triangle. Then I can write a congruency statement and say triangle ABC is congruent to triangle DEF. And it is that simple for an angle, side, angle triangle. So looking down below, next option that we have is we can talk about angle, angle, side. If two angles and a non-included side of a third triangle are congruent to two angles and a non-included side, of another triangle, then the triangles are going to be congruent. You need to fix that for me. Go ahead and get rid of included and say congruent. Okay, so let's look at it. Two angles. I know angle B and angle D. Sorry, angle A and angle D. I know angle B and angle E. And I know the segment BC and the segment EF. This is the special case. This is the only one we'll talk about where we're talking about non-included as opposed to included pieces. But we have an angle, and a side. So therefore, by our ASA or AAS, our angle, side postulate, we can say triangle ABC is congruent to triangle DEF. Looking down below, right triangle congruence. I want to take a minute and point out that this is a right triangle congruence. That's it. No other option. Okay? If it's not a right triangle, if there's not a 90-degree angle, we can't talk about it. So this one is a really easy one to eliminate as a possibility as you're looking at it. So looking below, if the hypotenuse and the leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay? So right here we have the hypotenuse, which is always across from my 90, is congruent, and one of the legs is congruent. So the hypotenuse would be segment BC is congruent to segment EF, and the leg segment AB is congruent to the leg segment DE. So because of those two pieces, this is called the hypotenuse leg congruence. We've proven that triangle ABC is congruent to triangle DEF. And just like we talked about last time, ABC and DEF could be written differently. We could have said triangle BCA and triangle EFD. That would have been perfectly fine if you listed your triangle congruence a different way. Again, the hypotenuse is opposite the right angle, and the leg is always adjacent to the right angle or next to the right angle. So flipping over on the back side here is your assignment for the rest of the day. Please go through here. Now notice that you have some side, side, side congruence. Oops, excuse me, I'm on the wrong page for you. You're going to have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg all show up in this next assignment. So take the time to write it down, look at what pieces you know, and ask the question, is it included or not included as you're going through? Is it a right triangle to help you eliminate possibilities and help yourself determine which type of congruence you're able to talk about? This has been Coach Ackner's Math, and I appreciate you watching. Have a great rest of your day.